Assalamu alaikum. I hope you all are doing well. So let's discuss about the theory of 7.2, and later on we will be discussing about the exercise as we usually do. So what is the takeaway or the bigger picture of the exercise 7.2 of additional mathematics? So it is talking about midpoint of line joining 2 points. Last time we saw the length of between 2 points or distance between 2 points. So today we will be talking about the midpoint of line joining 2 points. 2 points. So for example, we are given with 2 points. Say the one point is P, and I'll call its coordinates as x1 y1, and suppose we have another point, call it Q, and its coordinates are x2 y2. Then the midpoint, if we see its picture, the concept is something like this. This is, for example, you have P over here and Q over here. So this is line segment joining P and Q. We are interested in the midpoint, some point over here that bisects it. So this is my point M. And how do I calculate this point M? Is very simple. The formula is given by naturally the average of the coordinates x1 plus x2 divided by 2 and y1 plus y2 divided by 2. One can write x2 plus x1 divided by 2 and y2 plus y1 divided by 2. Let's do an example. For example, if we are given with 2 points, let's say the 2 points are, the point 1 is -1 comma 2, -1 comma 2, and point 2 is 3 comma -4. I am interested in the midpoint. So let's see how it looks like. So it's -1 comma 2, -1 is over here, so it's 2 basically somewhere here. So this is P1, and P2 is 3 comma -4, so it's going to be 1 2 3 and -4, 1 2 3, maybe 4, somewhere over here. So this is the line segment, if I'm not wrong. Oh, so crazy. Oh, forgive me for this crazy time. So I'm interested in some point, midpoint over here somewhere, that is bisecting it. So as we know that the formula for the midpoint is given by m equal to x1 plus x2 over 2 and y1 plus y2 over 2. So what is the value of x1? It is, let's call this x1 y1 and x2 y2. This is not necessary that you may call p1 to be x1 y1. You can call p2 to be x1 y1. It really doesn't matter. So -1 plus 3 divided by 2, and then 2 minus 4 divided by 2. So what we get is 1 comma minus 1. So somewhere here in the fourth quadrant, -1 comma 1. So this was about how to find out midpoint if 2 points are given. The question can be asked in another way as well. For example, if you are given with a midpoint and another point, and you are asked about what is the point. So let me reiterate what did I say. For example, we have 2 points A and B. We know the coordinates of B, sorry. For example, B has coordinates 3 comma 2, and let's say M is the midpoint of A and B. I'll call this midpoint between A and B. So midpoint between A and B is 2 comma minus 1. Now we can ask about this, that what are the coordinates of this A. So I can call this x1, y1. So now I know midpoint, but I don't know the coordinates of this point. So let's do this. So we know that midpoint between A and B is given by x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So just substitute the values. 2 comma minus 1 equal to x1 plus 3 divided by 2, and then you have y1 plus 2 divided by 2. So you just compare the coordinates. 2 points are equal if the corresponding coordinates are equal. So 2 is equal to x1 plus 3 divided by 2, and minus 1 equal to y plus 2 divided by 2. So from here you will get x1 equal to 1, and from here you will get y1 equal to minus 4. So the required point A is going to be 1 comma minus 4. So if midpoint is given and one of the points is also given and you are asked about other point, you will do that way. So now we will define some of the quadrilaterals. Let's define first trapezium. So trapezium is the quadrilateral whose exactly one pair of opposite sides is parallel to each other. We have already seen it. For example, we have this kind of quadrilateral, so you can realize that if I say A, B, C and D, then AB is parallel to CD. So since two of the sides are parallel, so it is a trapezium. Since one pair of two is parallel to each other, so it's a trapezium. For example, you can have this way. For example, you can have trapezium like that. Okay, so let's say this is A, B, C and D. Now you notice that AD is parallel to BC. So since one pair of opposite sides is parallel to each other, so this is also trapezium. Now let's define another quadrilateral, that is parallelogram. Parallelogram. So in trapezium, one pair is parallel to each other, but in parallelogram, both the pairs of opposite sides are parallel to each other. So in this case, what happens is both the opposite pairs are parallel. If you notice it, let's call this A, B, C and D, then clearly AB is parallel to CD and BC is parallel to AD. So both the uh, both the pairs of opposite sides are parallel to each other. So for trapezium we need one pair. So one is already over here. Additionally we have two. So you can say that if you have a parallelogram, since one of pairs of opposite sides is already parallel, for example this and this, if we forget about these two, then it becomes trapezium because we can't uh, uh, because we don't care about the other two sides. We in trapezium we need only one pair to be parallel, so one pair is already parallel to each other over here, so it is already parallelogram. So trapezium, so parallelogram, in other words every parallelogram is trapezium, but not every trapezium parallelogram is. So every parallelogram is trapezium, but every trapezium is not necessarily a parallelogram. So we have another quadrilateral named as rhombus. Okay, so rhombus, RHOMBUS, rhombus. So the parallelogram whose all sides are equal. So if we have a parallelogram whose all sides are equal, then this kind of parallelogram, assume that AB, CD, assume that in length AB is same as BC, is same as CD, is same as DA. So if we have such a thing in a parallelogram, then the parallelogram becomes rhombus. So since rhombus is parallelogram, rhombus is parallelogram, and parallelogram is trapezium, therefore rhombus is also trapezium. So rhombus is also a trapezium as well as parallelogram at the same time. We also have another quadrilateral, that is the rectangle. So rectangle is a parallelogram whose opposite sides are equal in length and all angles are of 90 degree. So rectangle is also a kind of parallelogram. So rectangle is a parallelogram and parallelogram is a trapezium. So you can also call rectangle to be a trapezium. So last thing that is left with is, so we have already discussed this, I'm not going into more detail. So the last thing is a square. So a square has also been discussed. Lastly, I'll comment that every square is rhombus and every rhombus is parallelogram and every parallelogram is trapezium. So in the same way, if if you say every